Hello and welcome to another Blender tutorial. In this video we're going to create something like this. I know that this can be achieved with particle systems, but this video is all about geometry nodes. The fields implementation of geometry nodes, to be exact. The finished blend files of the two animations you just saw, plus the one we're going to create today in this tutorial, of course, will be available to download from my Patreon page. So let's jump right into Blender and let's get started. Here I am in Blender 3, it is still in alpha at the moment. I prepared a little file here to get started. This is based on my startup file. If you are already a patron, first of all, thank you. And second, you already know this file because you can download that from my Patreon page. So let's do this. First of all, I think I'm gonna clean up the scene a little bit so I don't need the stage right now. And I think I'm just gonna delete all of these things here. Maybe even that one and that one. And you know what? I think I'm also gonna delete the one on the inside. So we're just left with this. Okay, then take my track 2 and put it down here because we know that we're gonna work with this and we're gonna have the bubbles coming out on top. So by the way, this entire idea is based on a video that I made here on the channel a while back, which was called Beam Me Up, and it was very popular at the time. That was done with animation nodes, and it was based on the faces of the geometry. So we kind of took apart an object into its faces and then made those faces fly up like Beam Me Up. So I wanted to recreate that, but in geometry nodes at the moment, at least, we cannot manipulate faces at all, basically. Or at least I don't know how to, I couldn't figure it out. So instead I thought, well, if we can't take the faces and animate them, how about we just create something else? We take the mesh, we sort of dissolve the mesh and create bubbles and make the bubbles like float up, right? So that's what we're gonna do now. So this is our rendered scene. I'm gonna take this editor viewport down here and go to geometry nodes. So this is like the very latest Blender. I think this is from 2 or 3 days ago I downloaded this. And the geometry nodes now have a lot of new nodes because they're heavily working on this. And we're gonna create a new node tree. So this is still group in, group out. But you know, with the new fields setup, we don't have this whole attribute workflow anymore, where we have all of those like the same looking nodes with geometry going through it. Then each node does some sort of function, and it's very hard to read. So I've complained about this in previous videos. So now we have the field system. It's much better. It's much more like the shader setup, and you will see very soon what I'm talking about. By the way, I have a video here on the channel where I take a first look at the fields setup in that test implementation. And that implementation, by the way, contains some nodes that are not available anymore. They were just in there to have some sort of a test environment to demonstrate what the fields implementation will be like. For example, the extrude node. So if you saw that video and you're looking for the extrude node, it's not there anymore. Maybe it'll come back. So anyway, enough. Let's do this. Let's get started. So first of all, we're gonna have to, I still want to use the geometry of this object for like the base of my dissolve and for the bubbles. So I'm gonna take this geometry. This is the input here on my geometry nodes modifier, and I'm gonna place some points on it because we can work with points. We can't work with the faces, like I said, but we can do points. And we know that we have a distribute points on faces node in geometry nodes. But what that does is it either distributes some amount of points randomly all over, or you can use the Poisson disk distribution, which is like it has a distance, all the points, so that they're not intersecting. But that's not what we want. We want to put one point where one face is. Like each face in our base geometry should now be a point. And there is actually a node in here now, which is the, where is it? Mesh 2 points. Here we go. So let's put that in here. And you can see where we used to have faces, we now have points. So like here it's very even, but around here where that object had that bevel, of course there's a lot more geometry there, a lot more faces, so we get a lot more points. And this is actually pretty cool looking when you dissolve it and make bubbles, because you get more bubbles are spawning here, and it kind of looks, it looks cool. I think it looks cool. So mesh 2 points, very good node to have. And here you can say vertices, edges, faces. Oh, by the way, I have to set this to faces. Now we have 1 point per face, 1 point per vertex or edge, or face corner would also be possible here, but this is fine. Now we have points. Now our entire original mesh is gone. All we have left are points, but we'll bring back the geometry. So let's just take care of that whole animation first. So I'm gonna look at this from front view. I'm gonna add a plane. I'm gonna take this plane, maybe scale it up a little bit, and then rotate it to something like this. Why am I putting it at an angle? Well, because if we're gonna move this plane from left to right, and we're gonna take a geometry nodes and calculate the distance from each point to that plane, okay? And we're going to use that distance to then translate the point upwards on the z-axis. So by tilting this plane a little bit and then moving that from left to right, we're going to have points closer to the top first, and then these points down here, they will be closer to this plane at a later point in time. So we're kind of dissolving from the top first and then the bottom. Right? It's just by putting this plane at an angle, we already know that this is going to be that. Right, so let's put this plane here. That's fine. Let's go back to our object shader ball. I have to click here. Okay, now maybe we should take this and give it a better name. Let's call it Dissolve Controller. Right? Okay. Let's go back here. We know that we want to animate or move these the points, the position of the points, and there is a node and it's called set position. I think this is also pretty new, but I mean everything is pretty new in geometry nodes. And here we can use our points. How many points do we have? If you hover over the output socket here, you see we have 8,947 points in this object. And here we can set those 8,900 something points to a new position. What is the new position? Well, now we have to think from right to left. So we have to think backwards, basically. We know that we need some sort of proximity calculation of each point to that plane. So first of all, let's get the plane in here. Input, object info. We can eyedropper this guy in, so we have our dissolve controller. And then there is a node, it's called geometry proximity. And you have to plug in the target. So with this whole new fields implementation, there's a lot of like backtracking going on. So this node works on its input geometry. Those are our points. And if we want to plug in a new position here that we have to calculate somehow, then this node will go back in this path here and ask these nodes for that information. Now let's just put this together. So we want to move the point on the z-axis. We know that here we get the distance value and we're going to use that for the z-axis, but we have to sort of invert it, because when it's further away, we don't want it to move, and when it's closer, then we want it to move. So we're going to need some sort of map range node. Already know that. Where would that be? Utilities, map range. We're going to plug our distance in here, and we're going to do something with it, and this result is going to be the z-axis for our position. So we have to create a combine a vector, because that's a position. Okay, now this is going to be something on the z-axis, and the x and the y we're gonna need from our original x and y position of each point. Right now they're all squished up here, x and y 0. Now ignore this offset checkbox just for a second, because I will have to talk about this whole backtracking thing a little bit more. So what do we need? We need the x and y position of the point, and we only want to change the z. Where do we get the x and y from? Well, in the whole field setup, you will get it from an input position. Now this looks like the simplest node ever, but think about it. If I take this position and I separate the x, y, z here, let's do that. X goes in here and the y goes in here, and you can see that we have something here that's from this. If I just plug the z back in, then we have our original object. So what actually happens here? This node knows that it needs a position for 8,947 points, and it's going to backtrack here and ask these nodes for 8,947 positions. So even though we're not plugging this in here somehow, this node knows or asks these nodes, and then this node knows that it has to be the position of this geometry plugged in here. So when I talk about it, it sounds very complicated, but think about it. We've been doing this with shader nodes like forever, right? We don't tell the shader node how many vertices does the object have, or how many pixels should it be rendering when it's rendering. It just, you plug it in, you tell it to use the geometry, use whatever. And here we're just telling this node, basically through these nodes, use the position of the point. This point that we plugged in here, this position is actually from here. Now, how do we add our value here? First of all, of course, we have to plug our c in here, and we're gonna have to add to this c. So we're gonna need a math node. That's, I think, in the utilities. Where is it? Utilities, math. So we're gonna add to the c our result, and that's going to be our new c. So what does that look like? Very interesting, very interesting. Let me move this. You know what? I'm just gonna put in a little animation here. Oh no, let's move it. Okay, so this isn't doing much yet. Why not? So we have a distance. We know that the distance can be from 0, so it's right on it, to something like a maximum. Let's plug something in here. And then we want to change this around. Oh, also we have to plug in relative here so that we actually get changes when we move this controller object. And then we want, if it's really close, we want to move it really far, let's say 20. And otherwise we don't want to move it at all. Okay. So now this looks like that. Interesting. So here we're far away, nothing's happening, and when we come closer, I think 5 is what I said, then the points start to move up. So this looks cool already. So now I'm gonna plug in a little keyframing here. So here we go on frame 1, we go I location, then at the end of our animation we move this over. I don't know how far, maybe let's just go here, I location, and so now I can simply scrub on the timeline to get my animation. Place this in the middle here somewhere. So this already looks interesting, and it's already kind of what we want, but it's very uniform. We need to randomize this a little bit, right? It's like too perfect. How do we randomize it? Well, let's add a random number. So utilities, random value. And it says random value, one random value, right? How is this even possible? we know we have 8,000 something points, but again, this node knows that it needs 8,000 something points, and we're backtracking here, so we're getting 8,000 locations, and we're gonna get 8,000 random values out of here, which we can just add to our multiply. I think we're just gonna multiply it in here. So we're gonna take this, multiply like this, and this is going to be that value. Okay, and then we can play with this a little, because we don't want it 0. If we have 0, let me see. If we have some very low values in there, multiplying by 0, those dots will never move. We don't want that. So we say, okay, 0.2 and then 1, that's good. So we have, see, now it looks much more random. It looks much nicer, especially for that. If you think about it, or if you think about bubbles, right? It looks much nicer. And that's all there is to that. Now let's go quickly back to this offset. So what does that mean? Well, here we're telling this node to use the position of the point. But we actually don't need any of these nodes here, because really what we need is a combine XYZ with a vector of 0, 0, and the delta C. So we don't need this add. That doesn't work because I need this value. Okay. And then I switch on offset and I get the same thing. Because now this node uses the position and just adds this as an offset on top of it. So we don't need this. But I think it's really cool to have this in here, because it shows off the fact that with this fields implementation, this node is gonna get 8,400 something positions from this node. And we're gonna use this, I think, again a little later, but for right now, I'm just gonna leave this in here. But we don't need them because we have that offset checkbox, very handy checkbox. Okay, so now this is already working, but if I split my screen here, if I go to camera view and go to rendered view, like this, then we notice it is completely empty. Why? Because those points that we're creating here, they don't have any visual representation. They don't have any mesh. No light can hit them, bounce off of them. So we don't see anything. Now let's make sure that we see something. First of all, we're gonna create a bubble. So mesh, icosphere, yeah, that looks good. It's very simple icosphere. This is going to be our bubble. And when we go back to this guy, we can go instances, instance on points. So now here we have the positions of those points. Those are our points. We're going to plug that into our output. And what do we want to instance? We're going to need another object input object, this, which is supposed to be our bubble geometry, instance this here. And now we have a whole lot of icospheres. Of course, they're way too big. So one easy way to solve that is to just go into edit mode over here and make it smaller. So now we have this. Cool. Now I can actually click on it because it's a something to click on. And now we can play with the scale here. And what we also want, we want a dissolve effect. So we want the original geometry, and then we want to dissolve. We have the bubbles here, but the original geometry down here. So we're gonna have to do that. Let me just scale this down even smaller so we just have some points. If we want this rendered view over here, we might as well right now take our bubble and give it a material so we can see something. The material, new material, bubble, shader, bubble. No, let's replace this with a glass, BSDF, pang, like that. So now we have little glass bubbles. They're actually pretty small. Maybe we should make them smaller, bigger. but I'm gonna take the IOR down to 1.2. The roughness, maybe a little bit of roughness. Okay. Now let's go back here. Let's go back to geometry nodes. This is a bit small. Okay, here we have bubbles. If we switch this off, cool. How about we plug our stage back in the background so we can actually see something there. Okay, now we have a whole bunch of bubbles. Let's take care of that original geometry situation thing. So we know that this is our original geometry of that material preview orb with the Blender logo in it. And these are our bubbles. But we don't want bubbles down here. So how do we do that? Well, first of all, we have to remove parts of our original geometry and keep what we don't want removed. And there is a node for that. It is the geometry separate geometry node. So we can plug our original geometry in here. Let's do this so that it looks neat. Okay. And here we can plug in a selection, which is just a like true or false, which part of the geometry should be included in the selection. And this would be the stuff that's not included in this selection. We're also going to talk about faces again here. So let's switch that to face. Now, what do we want included? We have this value down here. We know that this value is greater than 0 if our bubble is moving. As long as the bubble is standing still, this value is 0, right? So we're adding, with the offset here, we're adding 0. So it's very easy. We just need a utilities math node and go, okay, this is the value. If this is greater than 0, then this is our selection. Whoopsie. Wow, this is getting very small. Okay. So now here, if we look at this as an output, now we get this as a selection, and when we move, we get more, but that's not what we want. We want this part. Okay, so that problem is solved. We're already dissolving our geometry. It's a bit messy, but that's okay. Okay, so this is our selection. And also, if we look at this for a second, we have bubbles everywhere. We only want the bubbles where the geometry is dissolved, right? So we only want those bubbles. We don't want these. So how do we do that? Well, we already have our awesome selection thing here. And look at this here, where the instance on points, where we're instancing the icosphere onto the points. Let's just instance on those points, right? It's very easy. So here we're cutting away, here we're instancing points. And then how do we put this all together? Because we can either look at that part of the geometry or those points. But of course there's a geometry join, and we can join those two together. And then we have the original geometry and we have the bubbles. And if I move my playhead, let's start over here maybe. Oh, it looks cool. So we have this, and then here we have the bubbles. Is it me, or are the lights, why is there like almost no light in this scene? Let me see. Fill light, where are my lights? You, can you be stronger? I'm gonna give this guy a different material. Gonna create a new material. I don't know what to call it, but let me just switch over to the shader here real quick. Let's make this a glass too. But here I want like 0.4 roughness. Oh, and you can also see that this, hold on a second. If I hide this, you can see that this has geometry inside those bubbles. Do we want those? Yeah, nah, let's get rid of them. Delete vertices, Alt Alt H to bring back the outer stuff. And also these here, they could really use some loop cuts. So let's put that in here. And now we have a very nice object to destroy and dissolve into bubbles. So this is rather rough here, so we can actually see something. And then these bubbles, they're very shiny. I still don't quite understand why my lights aren't working in this scene.
A few minutes later.
Okay, I couldn't figure it out, but I just closed that one viewport here and opened a new rendered viewport, and now we have lights in there. Interesting. Anyway, well, it's still alpha, so now we have lights. So now one other thing. We want those bubbles, maybe I should switch this over, because with the rendered view, I only have one GPU at the moment. Then my recording starts lagging a little. But one thing we want to do here is the bubbles should get smaller when they rise up. Might not be physically correct, but it looks cool. So let's do that. Let's go back to our geometry nodes here. And then let's make the bubbles smaller. So these, this node here instances the icospheres onto those points that we picked here on that selection. This is cool. Okay, so we want the position of the point, and we want the position, not the original position that we used here. We want the position of the point of these points. So again, think about backtracking. If I plug something in here, we're gonna get the position. If I, hold on, let's just duplicate this guy. If I get this position in there, then that gives me the position of the already moved points. So we do that, vector, separate, take that guy. We're gonna do something with the C. What can we do? Well, we're gonna need two math nodes. Usually when you do stuff like this, you need an add or a subtract and a multiply. Multiply, so this goes in here and the C goes in here because we're only interested in the C location. And then this can be our scale. So what do we get? Per small. Okay, let's subtract a certain value. And when you look at it from here, you can see I'm moving sort of this range here. This is cool. So we want this to be up here, like out of frame here. Yeah, this looks good. And then multiply. We're gonna have to take the size down a bit so we get a nice size here where the bubbles are born, and then we get small bubbles up here. Cool. Well, this looks nice. We have random, we have a shrinking size. This is nice. One more thing though is when we look at this guy, where we are kind of ripping apart some of its geometry here. It is like infinitely thin, right? We want to add a solidify to this. So let me just save this before I add a solidify modifier. So if I add a solidify here, of course this is gonna work. We can also go here and enable auto smooth, and then on the solidify we can make it thicker. But if I select this geometry nodes, we're solidifying this geometry. So we're solidifying the bubbles and this part, which is not what we want. The bubbles don't need solidification. Now luckily, the solidify modifier, or almost all modifiers in Blender, has this vertex group input where you can say only solidify a certain vertex group. So wouldn't it be awesome if we could use our same thing that we used here for the selection, where do we want geometry and where do we want bubbles, to only tell this solidify modifier only solidify this geometry. And yes, this is possible. So let's figure out how to do this. First of all, we can plug stuff into these output sockets here, and then they appear out here in the modifier stack. And this is how we get attributes out of our geometry node into the rest of Blender. So we can even use those attributes in shader nodes, or we can create or fill a vertex group. Oh, first of all, let's create a vertex group, right? So let's create a vertex group. Let's call it, I don't know, Solidify. Oh, let's just call it solid. So this is going to be the untouched geometry, this part. Okay. And how do we fill this now? Well, in here we're going to have to say, okay, this geometry here, this is actually what we want to solidify. So we have to plug that out here somehow. But in order to get this into an attribute, we have to use a special node, and that is the capture attribute node. So we plug that in here. And then we to float, that's okay. And we plug the output out here, and then you can see out here we have this attribute. So this, let's call this untouched. Untouched geo. Like this is our untouched geometry. And we're gonna fill this attribute with a value of 1, right? Vertex groups have like a weight from 0 to 1. And this part of the geometry, this part down here, should all be 1. So it is part of the vertex group. We're getting this out here, and then we have it out here. And here now we plug that into solid, which is the same name as this. So you have to use the same name. So we're plugging that into there, and then we can use that here. And now we're only solidifying that part. So if I increase this now, I'm making this thicker, but the bubbles have no thickness, and they don't need thickness. So that's that. This is also very interesting. Now let's check out the materials quick. Okay, so our object has, what material does it have? It's called material. And this is that rough glass. Rough glass, okay. But our bubbles now also have that rough glass material, because we're generating these bubbles using geometry nodes. So basically they're losing their original material, which would have been the bubble material. So now how do we assign a material? Well, we only want the bubbles, which is this part here. These bubbles should have a new material. So shift a material, set material on the bubbles, the bubble material, and then that's that. Cool. So this guy is now this rough glass, very rough, obviously, a bit much rough actually. Okay, and then the bubbles are clear. And then really all I did was I gave my stage background a different material. Oh, also, wait a second. If we move over here, we're gonna get this plane into our rendered view, right? We don't want to see this plane. So let's select the plane, go here, and just make it invisible in the render. So it's still there. In the viewport, it might even be in the way in the viewport. So we could go viewport display and just set it to wire, so that it looks like this here. And here it's completely invisible. Awesome. Now, what did I want to do? Oh, background material, because this still looks like a cutting board material. Let's make it look somewhat like underwater. So let's go to the shader. This is that cutting board. We don't need any of this. Let's do something blue and a lighter blue, like that. And then for the mix factor here between blue and lighter blue, we're just gonna take a Voronoi texture, plug that in there, and wait a second. Scale. How can we do this? How can we make this look like underwater? Yeah, this looks This already looks like underwater. I know that my recording is always lagging when the GPU is rendering, but you can see Voronoi texture is like perfect for underwater. Mixing dark blue with light blue gives us this effect. You can even switch this to 4D. That's what I did for the render. And then animate this W value and give it a quick render so we can see what we've done in this tutorial. Let me stop it right there, because there's one thing that I don't like, and this is these super jagged edges here. So how do we get rid of those? Well, we have our geometry nodes, then we have to solidify, and after that we just plug a smooth in here. We only want to smooth that same vertex group, the solidify, and then we can just increase this, switch that off, so you see, and then we can smooth out these edges there. They don't get too smooth, but it helps a little, so that we don't get like this stuff. Cool. Now, one last thing. Where is this plane? It's just going, it's like, hold on, it's like this, and it's going from left to right, but it might look even better. And I think I also did that in the render that you saw. If we just rotate this guy, you can see we're now sort of, can we, so now this in the back. No, we're gonna rotate him the other way. We're gonna rotate him like this, so we can actually see into our sphere here while he's moving over. Cool. So we're dissolving the front to the back, and because it's tilted this way, we're dissolving top to bottom. And then all we need to do is render this out as a little animation. That's it for this tutorial. Let's just take a quick look at the original renders I made using this exact same technique. You can find the finished blend files of what you're seeing on screen right now, and of course the one we made in this tutorial on my Patreon page at patreon.com/chrisp. Let me know in the comment section down below, what do you think about the new geometry nodes, the new fields implementation? You like it? You understand it? What other tutorials should I make on this topic? There are new nodes being added all the time, so they're really working on this very hard. And all we can see right here now, and all the nodes that we already have, and we haven't even touched like the curve nodes and all that, and text nodes, they have been implemented in just a few weeks now, basically. So I'm very curious to see what's coming in the next few days and weeks and months. If you have any cool ideas for a geometry nodes tutorial, let me know in the comments down below. Thanks for watching. Chris P out.
For more awesome content, like and subscribe